So simply go to general and then property, and then steel database. So click on steel database, and then some sections will appear. So I will go to British sections, and then simply I will define any section. So let me define UKB 610, 229 and 113. Alright, so simply add this beam and close. So you can assign any section that you want. Now the section is defined. Now you have to assign that section. So click on this assign button over here. Okay, if you can see on assign button at this point. So click on assign, and then it says assigning, and then you can see that this icon appears. Now click on the member itself. So if you're clicking on the member, then it should actually assign. Yes, fortunately, finally it's been assigned. Okay, so and then this once section is assigned, then other thing is that you have to define the boundary condition, which means that you have to define a pin support at one end and roller support at the other end. So once this is assigned, then I will go to supports. Now over here I will create supports. So first is a pin support. I will say add, and then I will add another. This is a pin support, so I will click on this pin support, and I will click on assign, and using cursor to assign. And simply this pin will appear, and then I will click on the end node, left node. In that way, this pin is assigned over here. And now the next thing is to assign a roller support. So a roller support by default is not available in Staad Pro, so you will have to define your own roller support, and I think Warren will help me with that. So let's fix but, isn't it? So now fixed but fx is released. It means that it can move in x direction. And mz means that it can rotate in z direction. So it can simply rotate like this, and it can move in horizontal direction, isn't it? So add, then you have got this support. Now click on assign, and then again click on this node over here. Now this support has been assigned. The next and the most difficult thing is to assign loads, is to define and assign loads. But today it is simpler than the other day. So let's go to load definitions, and then let us first of all define a load case. So click on load case, and then click on add, then say that load case 1 or any load case, and then click on add. So you get a load case. Then now click on this load case. First I want to create a point load. So I will say add, and then I will click on member loads, and then now in here I will simply use two types of loads. One is concentrated load, other is trapezoidal load. With the help of these two loads, I will define loading on this beam. That is the simplest way to do it. So click on concentrated force, and then the load is how much? 20 kilonewton, but it has to be negative 20 because it is downwards. So 20, and then D1 dimension is that how far do you want it from end point. So you want it from 2 meters away from left, isn't it? And then D2 is obviously along the width, but I'm not.
That's a member. That's only a member.
Yes.
You should decide a member from.
Yeah. So 2 meters means that I'm taking this away from left support. So you can see over here that how far it is from left, and D2 forget about it because obviously I don't want it to move along the width dimension, so I will not enter anything. So minus 20 and 2 meter, and then click add, and then if you click on that again and then simply click on assign and then click on the member, the entire member, then it will add this load. Obviously you can control this by going to structure diagrams because this load looks quite big. So point force, if you say 10 and then apply, it is looking a little smaller. 15, if you click on scales and load scales, if you click on 15, then it looks quite reasonable, isn't it? So click OK, and then again go to load case and add. Now I would like to add another point load and then concentrated force. Now another point load is 20 as well, isn't it? And now this is how much away from left?
6 meters.
6 meters. So 6, and then add, and then click on that and click on assign, and then simply you can see this load. You can see its value over here. I think if you go to diagrams and then labels or something, so load points, member number, so loading display load values. So if you click on load values here, it will display load values. Alright? Okay.
Can you make it on AutoCAD also?
No. This will analyze it. AutoCAD will not analyze it.
Because on AutoCAD we can do the numbers, possible to do the numbers.
You can draw it, but you cannot analyze. Okay. Let's now the other challenge is obviously how do we multiply, how do we add this trapezoidal and triangular loading. So click on add, alright, and click on member loads, and first I would like and go to trapezoidal load. So in this I will simply use concentrated loads and trapezoidal loads. Now first I want to define this triangular load. Okay, have a look at this triangular load, and I want to divide it into two right angled triangles. So I want to divide it into first part from here to here, and then second part from here to here. Alright, now if you look at this picture, I have this trapezoid. So if I want to define first part, which is this part here, alright, if I want to define this part, then it is located at 2 meter, it is left point, its right point is located at how much? 4 meter, isn't it?
Mm-hmm.
So its left point has got 0 intensity, kilonewton per meter, its right point has got 10 kilonewton per meter, isn't it? Yes? So can I say left is 0, right is minus 10, and it is 0 at what distance? 2 meters, and it is minus 10 at what distance? 4 meters, isn't it? So then simply add and close. Now you can see that you can assign this, click on the load and then assign, and then click on the member. You can see that this load is assigned, isn't it? The next thing is to assign the second part, which is this bit. Now with your help, you will tell me, save, again load cases, add, go to member loads, and then simply trapezoidal. And now for this right part, I am starting at a distance of 4 meters, isn't it? And my ending distance is 6 meters, isn't it? And at my starting I have 10 kilonewton per meter, at end I have 0 kilonewton per meter. So can I say starting minus 10, and it is starting at 4, isn't it? And then ending is 0 kilonewton, and then end distance is what? 6. So add it, and then simply click on that, and then click on assign, and then the triangular middle load is assigned now. Now, I will define this trapezoidal load in two parts. One is from 0 to 3, which is triangle. Another is from this 3 to 5, which is kind of a rectangle, and then from 5 to 8, which is again a triangle. Isn't it? So if I start with the first part, then again go to load, and then simply add and member loads, and then simply go to trapezoidal load. Now, for me to define this first part, which is this part from here to here, which is this part. Okay. Now this part is, its intensity at left is 0, and it is starting from its intensity is 0, and then it is the ending intensity is 7.5, and it is starting from 0 and it is ending at 3, isn't it? So 0 to 3, and over here intensity is 0. At this point intensity is 7.5, but negative. Okay. Then click add and close. Now again click on this load, and then simply say assign, and then click on the member. It will give you a triangular load. Now the next thing is to create this UDL in between, which is from 3 to 5, isn't it? So from 3 to 5, click on trapezoidal. From 3 to 5, I have starting intensity as minus 7.5 and ending intensity as minus 7.5, because it's not changing. So minus 7.5 and then minus 7.5, and the starting distance is 3. The ending distance is 5. Isn't it? So 3 and 5, and then click close. So member loads, and then trapezoidal, and then minus 7.5, 3, and minus 7.5 and 5, add and close. So again click on this and click on assign and click on member anywhere, but it will assign it in the middle portion. Okay. Now the final bit is to assign member load, and then again trapezoidal, again this triangle, which is from 5 to 8, isn't it? So its starting intensity is minus 7.5, ending intensity is 0, and it is starting at 5, it is ending at 8, isn't it? So let us add this, and again click on this and then assign. So you can always show loading like this. So far so good. Loading is fine. So let us hope for the best and find out reactions. Okay. So let us analyze it first. Okay. So what do I need to do? Commands, and then analysis, and then perform analysis, isn't it? Yeah. So all, and then go to analysis, run analysis, save. Okay. So fingers crossed. Let's have a look at reactions. So where are reactions? Post-processing. Sorry. And then reactions. Are we getting right reactions? Bravo! Finally, we got it.
non mi viene.
And perhaps this, I think there wasn't much point in extending the deadline probably, so...
No, 2 weeks.
Because now you know it, so you can just... Okay, now if you wanted to see kind of bending moment and etc.
Did you
simply
have you recorded it?
have a
Did you
look
do a mini mass fit? Did you send
on
it?
view,
Thanks, man.
structure diagrams.
I was getting one, I'm not going to lie. I didn't about getting crushed.
You can have a look at its bending moment diagram. So simply go to view and then view diagrams, and then if you want you can have a look at bending moment diagram, apply, and then if you wanted to if you wanted to see its labels, then go to results and then go to view value. Okay, then simply beam results say that maximum bending moment, and at midpoint annotate. Now this is giving you value of bending moment, isn't it? So if you wanted to have a look at shear, then simply again go to view structure diagrams and then simply load, and then instead of bending I think it's shear Y, isn't it? So apply and then click OK, and also results and then view value, and so in here probably ends, maximum, midpoint, annotate. So here you can have a look at value of shear force. If you wanted to have a look at different, you can divide this into parts to have a look at different values. So in that way we work out, in that way we solve this kind of continuous beam. Not continuous beam, a beam with variety of loadings.
We have to submit background questions or just this?
How do you submit? Just screen? Do you like make screenshot and then submit it on the...
Do a screenshot, or it has I think some kind of report as well. So beam end forces, section support reactions. Yes, sir.
Can we don't do it by the hand?
Or you could take screenshots as well.
I went that bad.
Sketch by the hand.
Can you do it by the hand?
Sketch and the structure grid.
Later gonna show you what to
Yeah, sure.
Location of beams and columns only. And grid.
Design.
Design. Yeah, just don't want it to just be like Huawei.
Have you done truss?
Truss. So we're trying.
This one?
Yeah, we're trying.
Do it. Michelle, you are behind.
last week.
If you have, then that's fine. And do it on a Staad Pro as well. And I would like to see the C part. And for coursework part C, I would like to see part C completed today. I would like to see how
Shit.
you're getting on with
I
part
haven't
C.
got it on me.
Without part C, nobody can.
Don't have it.
Nah, I haven't got it on.
There's no point.
There's no point. Okay.
Where is this street?
Without part C, it will be very difficult. Most load. So in beam, obviously you might be using primary secondary beam configuration. So if you are using primary secondary beam configuration, then you have to design primary beam, secondary beam, and a column, at least these three elements.
Yes. You have to do it for A3?
Drawings should be on A3.
Yeah.
I think that's scanning on.
Can we do it on AutoCAD?
I've got it turned on.
Drawing the vendor? Only the vendor.
It's in light.
You can, but this is not drawing. This is finding the
That's
reaction.
not something.
Okay, one more thing. If you do the AutoCAD vendor,
so
if
many.
you have to draw
Yeah.
what you have to do today. It's not for the moment to the
So-
Je sais pas, je regarde.
I would like to take questions on coursework for half an hour or so, and then we will go. We will go for this I-Structure President's address. This is very important to attend. Please attend this Nick Russell's presentation today, starting at 2 p.m. And please let me have the room as well. I think it's AB
4 p.m.
Oh, no, looks like we missed it.
Start at 4.
p.m. It's 4
Start at 4.
Yes. Yes.
Normally do with this, you know, the rafter tie the internal members.
Yeah.
So how do we?
So rafter is these members, top ones.
Yeah.
Okay, and main tie are these horizontal members. Okay,
Okay.
and internal members are these vertical and inclined.
Okay. 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 But when using the Staad Pro,
Yeah.
we need to insert.
Yes,
This is the result what we're gonna get,
yes,
and we're gonna do like
yeah.
Okay.
Simply follow this
procedure.
PDF file
Yeah.
and try to do it this bit.
We
Right?
need to
Have you
design
done it?
for no, not yet, but
not yet.
the calculation we have.
Yeah.
Just we need now to know exactly what we can do. But now we know we need to design before this line.
If you sit on this software and then if you try to follow that PDF, then this is just a data change.
Yeah.
So you will be able to do it, and you should actually show me how you did it or something. I can help you.
Okay. And lastly, about this one. So
Yeah.
here we need to use the GKQK.
Yes, yeah,
Yeah.
yeah. Here, I mean, I'm interested to see how you put beams in. You have done it.
We try to analyze, but we are not sure. Maybe.
So
It's a concept. It's not sure, but we try.
this is the
maybe.
concept. It's a good concept. I just want to see the.
Because this column is one.
This is not a beam. This is a very long beam.
Yeah.
It can't be like that.
Okay.
So you have these columns. I would like you to divide this in a kind of structural grid. So for example, if you use 5 by 5 or 5 by 10 grid.
Of
and then-
7.5.
Yeah, and then I would like to see spanning direction of the slabs as well.
Okay.
Yeah.
I'll do the calculation of that.
Yeah. So first you need to work on this. At the moment it's just architectural plan. So I need to see this kind of simply don't draw it.
No, I'm not
Simply,
sorry, but that's the idea.
try to put something like some kind of columns here and here and see how does it work. So it should have a kind of a structural grid. Isn't it?
Yes.
So for example, if you what you could do is that you should have this is how much? This is 19. 19 or 18?
18.
18. So you could divide it into like so you could have one column here and one column here, and then you could have like
We need to ignore
So-
this,
so this-
the window. The window.
yeah, it should be above. Don't be so 6 meter, 6 meter, and 6 meter. So then follow this line. So I'm not sure where this will
Yeah,
come.
that is the idea.
So then
Go all the way across
you
straight.
will have all the way across, then you will have all the way across, and then you can divide this into
Because 5 by 5 grid.
Yeah.
5 by 4 free grid.
5 by 5 or something. So then you can have columns here, here. I'm not sure about the distances. Obviously, you have to work out if they.
You know, though,
They are fine
that's
or
what
not.
you're doing. For me,
So-
I know that.
Yeah.
I know that, but
Okay.
I can say,
Yeah.
oh, if I'm gonna modify this plan.
No, no, you
maybe-
don't modify the plan. You just try to put the columns, and then once you have these columns, then you have sticks as beams, and then you give me the spanning directions. For example, your slab is spanning in this direction,
Yes.
and
Off.
your slab is spanning in this direction. Then you show it to me like this. I know you know it, but I can't see it on the paper. So you have to show me on the paper,
Yes.
isn't it?
Okay.
So do not overcomplicate the things.
If I wanted to
I
find
just-
an example, what would I be able to type in Google?
On Moodle, if you have a look, this is, if you have a look at lectures or essential resources, and if you go to library, then you have this one, SCI P387 worked example. Now this guide is really very useful. What it tells you that
Io mi consiglio finalmente. Te dico la capita.
so here, so if you open this example,
Yeah.
you can have a look at. So in this guide, what it does is it is for students. So you have this structure, and it tells you the spanning direction of the slabs, and then how do we design it, bracing, and etc. So it tells you.
Materials as well?
Yeah, it
Yeah,
tells you
everything.
everything. So you design a primary beam as unrestrained beam, and you design a secondary beam as fully restrained beam, and also you have column design as well. So you have design of all those members. So follow this, but obviously
They give more
your
consistent.
your dimensions will be different than this. So you use it as a resource to see that how to design the entire building.
Okay.
And obviously, I've covered quite a lot of topics
Which should
in lectures as well, like compression members, beams, and etc. So this will follow the same kind of procedure, but it is in a building sense.
Thank you.